we will talk about numerical integration, and this is using numerical methods to find area under a curve. There's two rules that we're going to go over. One of them is Trapezium rule and the other one is called the Simpson's rule. So if you just have a look at a function which is you want to find the area of the definite integral, let's say between a and b. So what we've done so far is, and this is highly accurate, is you integrate or find the definite integral from a to b of the function that you have, and that'll give you the area. Cool. So how can we actually do that using numerical methods and concepts? Let's have a look at that. So for a function which is a curve, it can be divided into equal number of equally spaced out areas, and these lines are called ordinates, and we label them starting with the first line as y0, and then y1, then y2, y3, y4, and then the last one will be, let's say, yn, whichever it is, and the one before that would be y of n minus 1, the one before the last one. So, and there's can be a whole bunch in between. So depending on how many of these you actually divide by, the spacing between the lines would be the same. So like you've got x naught here. I'll just use a different color, sorry. So it's x naught, let's say x1, x2, x3, x4, and that'll be xn and xn minus 1. So the thickness of each strip, we'll label them h, and they will be consistent. So h usually would be xn minus x naught over n. So pretty much the whole length from there all the way to there, divided by how many times you are slicing it, pretty much, and that's h. So if you remember a trapezium, so in a trapezium you have two parallel sides, and then that would be the h, or the height, and let's say this is a and let's say this is b. So if you go area would be equal to h over 2 into a plus b, or h times a over b, whole thing divided by 2, whichever way you want to go. So from the diagram here that we have, see if we can identify which part is what. So the h here is the thickness. So if you compare that to here, the h would be the thickness, which is equal, so that's h. The a and b would be the length of the, we call these ordinates. So the length of the ordinates, meaning y. So you've got an x and you've got a y point. So that length from there to there is your parallel sides. So moving on from here, let's see if we can derive the equation for trapezium rule. So pretty much what we're doing is we are creating trapeziums of, as you can see here, of each strip that, and we've got these as the parallel sides. The area from there, so let's say what we do is if you want to find the area from all the way from xo to xn, it'll be like a1 plus a2 plus a3 plus a4 plus an minus 1 and an. So if you take the area for a1, for example, the area a1 would be equal to h over 2, so that's h divided by 2, that's fine, and a and b would be y0 plus y1, and the area a2 would be a2 would be h over 2 into y1 plus y2. That's y1, and that side would be y2, and so on. And if you add up all the areas, we will end up with the formula for finding area under a curve using trapezium rule. Let's get on to that. Alright, so if we have 4 sections, for example, starting from here to here, if you wanted to find the area, let's say A1, and then A2, A3, and A4, so from there to there, all the way between here. So let's write down area equals A1, let's say, plus A2 plus A3 plus A4. So there's 4 divisions, and we can include n minus 1 and n for various number of strips. The more strips you do, the more refined or the more accurate your picture is going to be. Okay, so if we add the areas together, so we have A1, which will be h over 2 into y naught plus y1 plus h over 2 into y1 plus y2 plus h over 2 into y2 plus y3 plus h over 2 into yn minus 1 plus yn. So if we now factorize h over 2 out, we'll end up with h over 2 into y naught plus y1 plus y1 plus y2 plus y2 plus you end up with yn minus 1 plus yn. So if we simplify this further, you'll end up with there's always going to be 2 of these and 2 of these all the way, except for the first and the last one. So you can have height 2 into y naught plus, you can bring the last one in front, yn, plus 2 times y1 plus y2 plus y3 plus yn minus 1. And that is how you find area using trapezium rule. So this is the derivation of the formula to find area using the trapezium rule. Now okay, so if we have a function y equals 1 over 2x plus 3, for example, and we are asked to find the area between the curve and the x-axis starting at x equals 1 to x equals 3, and we want it divided into 8 strips, which I have done here. So the question is, let's say, use the trapezium rule with 8 strips to calculate the approximate value of the definite integral going from 1 to 3 of 1 over 2x plus 3 dot dx. So let's, just for comparison's sake, we will do it both ways. We will first do it with the formula, we'll first do it with the actual integration, and then we'll do it with the formula. So if we were to do this, we'll end up with so using integration, you will end up with the definite integral of 2 over, it'll be 2 ln of 2x plus 3 from 1 to 3. And if you do the calculation, you'll end up with 0.294. Now if we use trapezium rule, first of all you have to find the width of the strips. To find the width of the strips, you will go, it's h would be equal to 3 minus 1, which is 2, divided by 8 which will give you 0.25. And so you substitute, or you can create a table of values, which I've done here on top, with all the x naught all the way to x8, and then you substitute them in the equation y equals 1 over 2x plus 3 here, and you get the y values. So you have a table of values of x and y, and then you write down the equation. So area of a trapezium rule would be h over 2 into y naught plus y n. Yn would be 8 plus 2 times y1 plus y2 plus y3 all the way to y7, which is the second last there. And then if you substitute, h is 0.25 divided by 2, y1 would, or y0 would be 0.200 plus 0.111 1 plus 2 into all the values that you have, and if you plug in the formula and you do it in a calculator, you will end up with 0.2942. 2942 is your answer. So you can see clearly that the trapezium rule, which is an approximation of the area, which is 0.2942, and the actual value of the, using calculations using the definite integral, if you use three decimal places, they are pretty much the same, 0.294. 0.294. As you can see here, that trapezium rule is a very close approximation to the actual value of the area using integration, and that's how you use the trapezium rule. Cool. Let's move on to the Simpson's rule. So Simpson's rule is one of the other ways of using numerical methods to calculate the area under a curve. And if you just refresh on trapezium rule, you sort of divide the area you want to integrate between, let's say, A and B into strips, and you form trapeziums. But they are not highly accurate because you get usually, especially in a curve, you're trying to use straight lines. And so important point to remember about this is, if when you start labeling them, then this is y0 and y1 and so on, and the x would be x0 and x1 and so on to the xn and yn. When you have an area between curve of a similar function using Simpson's rule, what Simpson did is he just divided them into two. So instead of using a straight line, he used a parabola to model the curved part, and therefore his equation is slightly different. But so according to his rule, his equation is the area is approximately equal to h over 3. And so depending on how many strips, if you have 4 strips, for example, there will be still h into y0 plus y1, sorry, not y1, yn, plus 4 into y1 plus y2 plus y3 plus yn minus 1. Plus 2 into, sorry, hang on, I made a mistake here. Okay, I'll start over. So the area using Simpson's rule is h over 3 into y0 plus yn, that's the first and the last ordinate, plus 4 into, and then you do 1 plus y3 plus yn minus 1. So you do the odd number ones, and you multiply the odd number ones by 4, and then you go plus 2 times, and then you do the even number ones, y2 plus y4 plus yn minus 2, because that will be the even one. And that is how you use Simpson's rule and approximate the area of a between the x-axis and the curve. So again starting at the original is y0 and going all the way to the last one. So what you do is you add up all the odd number ordinates and multiply them by 4, and add up all the even number ordinates and multiply them by 2. So to use Simpson's rule, one of the things you have to keep in mind is the number of strips you divide by has to be even, or else this won't work. Whereas in a trapezium rule, it could be either even or odd. It'll work usually. But we try to usually keep it even, but it could work either way. Whereas in Simpson's rule, you have to divide the strips evenly. Okay, so I won't derive the Simpson's rules for you, but let's have a look at how we can use Simpson's rule. All right, so let's say our example is, let's say we integrate between 1 to 5 log base 10 of 2x dot dx. And let's say we have to break it down into 8 strips, so x0 all the way to x8. And so we divide 5 minus 1, you get 4. 4 divided by 8 gives you 0.5, and therefore the difference between these are, as you can see, starting with 1 and going on to 1.5 all the way to 5. And so that is equal to h. Now if we were to use Simpson's rule, the area would be equal to, let's substitute, so h over 3, so 0.5 over 3 into, so you add the first and the last terms, which is 0.3010 plus 1, so the first and the last, which is 1, and then plus 4 times then you add up the rest, 4 times 0.4771 plus then you add up the odd numbers, so that's y1 and then y3 and then y5 and then y7. So sorry, it keeps jumping. So 4771 plus 0.6990 plus y5 would be 0.5451 plus 5451 plus 0.9542 and then plus 2 times then all the even ones, which is 0.6021, that one, 0.6021 plus, and then the next one will be y4, which is 0.7782 plus y6, which is 0.9031 plus 0.9031. Sorry, that's the end because the other one would be already added on. And if you plug them all in the calculator, you end up with 2.96156. 2.96156. Depending on if you wanted to make it to 3 decimal place, it'll be 2.962 if you want to. Now, if you actually did the integral from 1 to 5 of log base 10 of 2x dot dx, you'll end up with so if you substitute the numbers, you end up with 2.962. That is up rounded to 3dp. So you can see that to 3 decimal place they are exactly the same. So you can clearly see that Simpson's rule is quite a good approximation of a actual integration. So to calculate the area of a curve, you can use these numerical methods to be able to calculate an approximate area of the curve. You just have to be able to use the formula. So the formula will be given in the formula sheet. All you have to do is create a table like so, or table might be given to you. Label them from x0 all the way to the number of the number of strips given, and y0 to the number of strips given. Substitute the numbers, work it out, and get the answer, and keep the answer to at least a significant number of decimal places. I mean, to say at least 3 decimal places if it's small. Yeah, so the only thing to note is the labeling start from X naught. To get the H, all you do is you take the top limit, the bottom limit, and then divide them by the number of strips you have. Minus them, divide by the number of strips you have. And there you go. So please do practice some questions from either past year paper or from the workbook. And yeah, skill up on numerical methods.